how we can take the steel industry to the next level, and today we have elaborated various technologies that can decarbonize. And as I stated in the just previous session, that blast furnace technology is going to remain, whether you like it or not. But there are other multiple technologies are going to play significant role. We touched upon CCUs as well. But this session is particularly important for two reasons. One, that what are the alternatives we have and what are the innovative alternatives we have. We talk about hydrogen, we'll explore that in this session, how hydrogen can be a technology for the future and how we can reduce that to become cost-effective solutions. But interestingly, when I was talking to some of the panelists, we found very innovative technology, whether it is a biomass utilization or simple creating a wealth from a waste. I think Anilji will elaborate on that, very interesting session. I personally looking towards that. We have research from NIT and we are looking towards that, how we can take the research to applications, gasifications. I think we have a very interesting panel. Let us hear to that. The reason again, I'm very confident and I'm convinced that decarbonization in the steel sector or modernization, let me tell, modernization of steel sector will not depend on one technology or one technological partner. It is going to be a combination of multiple technology, and those innovative technology are going to take our industry forward. And India is in the rising. And if you look at, when we look at the steel sector, globally we are having overcapacity, but here the region we are growing. And we have a very high aspiration of growth. To support that, I look forward, all these technologies are what we are going to listen today are going to support those growth. I now hand over the session to the moderator to take it forward. Thank you very much. Look forward to it.
Thank you, sir. As we have listened so far, steel sector is very hard to abate. And India is growing very fast, going to become the Viksit Bharat by 2047. We have about 200 million ton steel capacity, going to be about 300 million ton by 2930. And the domestic demand is very robust, infrastructure, construction, housing. But at the same time, we have Paris commitment for greenhouse gas emission reduction. So this session is particularly focused on use of alternative fuels. Basically, carbon emission is because of the use of fossil fuels in the steel sector. So these alternative fuels like hydrogen or other biochar and other things, which can reduce the carbon footprint in the process. So government has also announced a green hydrogen mission. So almost 19,000 crores of investment budget is there for incentivizing manufacturing electrolyzers, then creating infrastructure, promoting pilot projects for green hydrogen, then promoting R&D programs, skill developments and all. So, and steel is also one of the sector which need to be exploring the use of hydrogen. Ministry of Steel, as you have launched some pilot projects for use of hydrogen in blast furnace, in rotary kiln, both vertical and horizontal, and a lot of pilot projects are going on. So this session, we have eminent speakers, Mr. Professor Bankim Chandra Roy. First paper, the topic is sustainability through synergic integration of steel substructure and FRP superstructures. He is a professor of NIT Rourkela. He has been working there since 1989. He has also served as the Dean of Faculty, Head of the Department of Metallurgical and Material Science, incumbent coordinator of the Steel Research Center at NIT Rourkela. He completed his BTech in 86 from Jodhpur University, MTech in 88 from IIT Kharagpur. He was awarded PhD from Indian Institute of Technology, Kharagpur in 1993. He made immense contribution in the field of phase transformation. Sorry. Heat treatment and composite materials. He has guided 18 PhD scholars and many master graduates. His research interests are mainly focused on the mechanical behavior of FRP composites. He is leading the composite materials group at NIT Rourkela. He has contributed extensively in the world literature in the field of material science, holds 2 patents derived from his research, nearly 225 publications in SCI international journals, 50 in national journals to his credit. Professor Rai also authored 9 books, and he is also a member of prestigious societies like Indian Institute of Metals, Indian National Academy of Engineering. He has been listed in top 2% scientists list by the Stanford University every year since 2020. Has been ranked in #1 researcher in glass fiber composite by scholars as an advisor to new material business. He has worked in Tata Steel. He has been instrumental in facilitating the steel onco foray into the FRP composite business. So over to you, sir. Kindly restrict your presentation to 8 minutes. 8 minutes, and you will get a signal at 6 minutes.
Good afternoon. I am honored to be here. I am really thankful to the organizing committee for such a beautiful, well-organized knowledge sharing session. I will take your attention for only 10 minutes because it is different. It is different, entirely different. And the talk has no intention to make smart steel outsmart, to make it a smarter. So I have been talking from the yesterday, the sustainability and the efficiency is not so well defined. So holistic understanding is very important. We are talking about technical integration, but we are not talking about the material integration. So that part we are going to talk. So steel with a history of more than 150, nearly 200 years, we are really addressing the issue which we could have been addressed much before. And we are thinking of 200, 300, 500 million ton. Absolutely no problem. But to make it a synergistic sustainable, we have to think not only holistically, but synergistically. So actually, I have written so many background. The reason is that all of you know aware about the Tata Steel. But for last 7-8 years, Tata Composite. And I'm very privileged that I am the anchor person for that. And it is a good growing business. The growth is not exponential. The reason is that because the competition is very unethical from the unorganized sector. Okay, so composite is already being used all over the world because it is lighter, it is stronger, and almost close to 100% corrosion resistant. But you know, one of the Achilles heel of steel is the corrosion. Nearly 4% GDP loss for the corrosion. And you have to address it with a war footing. Otherwise, there will be a premature, unprecedented failure, and there will be a casualty. So, if you think not only with the technological integration, if you think about the material. So, this is the picture taken just one day before. We have made it in our laboratory. It's a crash barrier member. Highway crash barrier member, multi-material concept, where steel is there, polymer is there, and also FML, fiber metal laminate. And when there is a severe accident in a highway, the accident is mostly fatal, taking the life of the driver, most of the, and car fully damaged. And it is operational in Bangalore, the shorter version, the economical version. Now, if a car with a high speed, crash with this member, the kinetic energy will be converted to rotational energy. And you believe me, this particular material development we have been doing, it has gone to the 6th level, and we have been recognized, going for patent. There are some things. So it is a multi-material concept. One of the biggest advantage of FRP is that with less deflection, it can absorb more energy. And the toughening mechanism is 1000. These are the limitation with the legacy. But one thing I'm telling you, by all degree, I am a core metallurgist. Okay? I have no reservation to respect the steel legacy. Okay? But you need to be lenient with the new born baby. Okay? With more promise, more potential, and more penetration. Okay? But the things are not happening. There are 100 unorganized sector, even in India. Okay? And they are really taking the reputation in a downgrade level by making composite, not making it properly, perfectly, without R&D support. You see, look into the steel. It has more than 150 years of billion dollar research. But still we have a problem. And we are investing so much of money. Okay, but still going on. Things are going on. So steel is a smart material. We need to make it smarter, whether by technical integration or by material integration. So this is not the dream. This is the things we have made it. Not that we are the first person, but FFL fiber metal laminate is our innovative idea, which are there in the third line. Okay, so if there is a very severe accident, which is really regular and routine, the problem with the driver, with the car, with the crash barrier will be reduced drastically. And no doubt about that. Look into this Burj Khalifa to draw the attention, because I'm going to talk about the substructure and superstructure. So substructure, which are really taking the load of the superstructure, which are lying above that. And you know, the upper part, 39,000 ton steel used. But you know, the upper part, there is an integration of material. There are titanium, there are aluminum. And the ground portion still is there, but the corrosion is a big issue, and they spent a huge amount of money to take care of that. Now, thing is that what we are going to talk about, whether the upper part can be replaced by the FRP, because under the loading, it has a less deflection. So moderate seismic ductility may be less with the FRP, but the moderate earthquake, Richter scale earthquake, the FRP is a better. And I will come one by one. So still, this part is not so interesting. So this part also, because there is a time constant. Steel is there, it will remain there. So what I mean to say, I'm coming here. This is the problem with the steel. Just look into it. The corrosion, from the first day, the corrosion. Okay, and you have to address it in war footing. You see, and the composite for 20 years, almost zero maintenance. So there are common question from the audience. The initial cost is very high. Yes, but the life cycle cost is very less. So these are the advantage. So I have to be very fast. Carbon footprint. Let me tell you, for the production of FRP composite, the carbon footprint, carbon emission is less than the steel. And if you look into the property comparable, especially in the mobility sector, aerospace, naval, marine, then railways, composite potential and penetration is really very, very high. And you need to welcome it either today or tomorrow. Because most of my lecture I'm delivering in the steel industry, either Tata or Jindal or Reliance, like that. I'm talking about that. It is happening and it has to happen. When there is and you look into the specific modulars, the absolute modulars is less, but the specific modulars for the mobility sector, FRP is undoubtedly the chosen material for the, and let me tell you, because time constant is there, Government of India has an initiative for the future new structural material. I am honored to be the composite person to make the white draft. So things are happening. So if you look into the steel, you know, taking huge amount of energy, composite is not. So really these are the advantage, weight saving, infinite design concept, many, many things. But one drawback like corrosion, the shear modulus is less. Okay, let me tell you. So taking the full advantage of a lighter and almost 100% corrosion resistant steel, being a stronger, ductile, that can be combined. So
Sir, kindly conclude.
If you look into the very guideline, the composite location is much above the steel. So either today or tomorrow it is going to happen. This is the talking I'm talking, that with less deflection, it absorbs more energy. Look into the problem with the steel. Okay, and you know, the Dreamliner, the full fuselage made of complete FRP structure with one component, and 50,000 fastener reduced to zero. Okay, and this body area type of crack will not going to happen. Okay, I'm so sorry. So things are happening if you are accepting or not. So, so what I mean to say, there is a huge technical tangibility to combine the steel and FRP together and making the steel smarter and synergistically sustainable. That's my, but one word is missing in the international conference, durability, where the FRP has a much more cutting edge than the steel. So so many bridges, superstructure, and this particular, just a minute, Apple made a biggest office in California. The roof is totally made up of FRP.
Please conclude, sir.
So I am closing here. So you look into the mega structure, turbine blade put into the inside the sea to take the advantage of tidal energy converting to the electrical energy, which is not possible with the steel. So but the connecting with the steel and the FRP is a challenge, but things are happening. And the rebar, okay, and the rebar, you know, the FRP rebar is coming in a very, very big way. So thank you, and for so compulsion, I have to stop over here, but I will be very happy to have many, many questions from you, because it is different and acceptance needs more clarifications, but don't reject the idea, because composite is a better idea than the alloy. No doubt about it. Steel is an alloy, FRP is a composite. So concept is much better, much mature, much more technically sound. Thank you very much.
Thank you, sir. Question answer we can have at the end of the session. So our next speaker is Sri Anuj Agrawal. The topic is natural gas for infrastructure and steel sector from GAIL is from GAIL. So he is Chief General Manager GAIL. He comes with an experience of about 25 years in the field of natural gas marketing. He worked in LNG sourcing of first LNG contract in 2004 and has developed market on imported LNG in various parts of the country. He worked in various parts of the country, including also in Singapore. Please.
Thank you. Good afternoon, everybody. Thank you, Mikon, for hosting GAIL and a very wonderful conference. So two buzzwords, sustainability, which was the session before this, and natural gas, I think befits this time that we should talk about natural gas also. So I'll be taking you through a couple of issues which natural gas has advantages in steel sector. By the way, just to inform you, as on oil and gas, we are one of your big customers also. So the more you produce steel or more green steel is produced, we have a lot of appetite in terms of pipelines. So we'll be talking about the global energy scenario, how the energy fixings in terms of coal, oil and gas, how about the India, how it works, something about GAIL, and what are the infrastructure we are developing for development of natural gas in the country in particular, about Jharkhand, what all GAIL has done in Jharkhand, and some benefits of natural gas. Just to give you an overview, the world consumes 26% of coal, 33% of oil, and 23% of natural gas. This is the world consumption in terms of prime energy. Rest is renewables, hydro, and nuclear. India is a big consumer of energy, but our natural gas or the cleaner ones is on a lower side. Just to give a perspective of terms of LNG, the global trade is around 400 million tons, the dotted lines, which is going to go up to 600 million tons by 2030. Takeaway from this slide is that there is a lot of LNG available at very competitive price in coming years. Coming to the India mix, we are 60% dependent on coal, 28 on oil, but if you see the world average of natural gas around 24, we are just 7%. Same percentage is reflected in renewables, hydro and nuclear. So I think the pie of natural gas and the renewables has to go up in coming years if we have to decarbonize, sustainability and look for the climate changes. India is fourth largest importer of natural gas today after Japan, Korea and China. So what I'm trying to bring here is we have done a lot of work on infrastructure in terms of natural gas availability, regasification, pipelines, and delivering it to the customers. This slide, what I want to take away is, we are today doing 200 million standard cubic meters of natural gas in the country. Around 99 is the domestic production. Similar amount, around 102 comes in form of imports. So what we can say is 50% of the domestic natural gas is produced in the country and rest is imported. By the way, all the prices of imported gas or be it the domestic gas is by and large aligned today. And there is a huge competition between the imported gas prices vis-a-vis the domestic gas prices also. I'll take you to the last bar, the 201, which shows the sector-wise consumption. If it go from the bottom, 27 is consumed by power. Fertilizer, the entire urea in the country is produced on natural gas today. There is no naphtha, coal, nothing. 17 is by refinery. So refineries have also started using natural gas. CGD is a big customer, around 42 MMSCMD. So the household gases, what you get in your kitchens is all CGD, we call it. The vehicles, the CNG which runs is CGD, we call it. And the industrial and the commercial, the hotels, small industries also use natural gas. But in the sponge iron, we see the green one, it's around 3 to 4 MMSCMD only, just 2% of the total consumption of the natural gas. Miscellaneous sector, if you see the light blue on the top, has grown significantly. When I say miscellaneous means it can be a tile, it can be an automobile, or it can be like Maruti, we are a customer, so car manufacturing, all these small industries also use natural gas for various requirements. Just to talk about GAIL, we have a pipeline of around 16,000 kilometers pan-India, right from north to south to east to west, which we operate ourselves. In terms of our LNG portfolio, the world has around 400 million tons. As India, we are 27 million tons. GAIL does around 16.5 million tons. We are into polymers also, but I think that won't be relevant today. We produce LPG also. Very few people know that GAIL produces LPG. But the cylinder, if you get at home, at times the LPG is made by GAIL. We have E&P interest. We have 13 blocks, 3 overseas and 10 in India. We are into renewables also. And we are in a big way in city gas. When I say city gas, the gas you get at home is largely supplied by GAIL, either in the front end or the back end. It may be a GAIL company or a GAIL joint venture company who is giving you gas. But at the back end, it would be always GAIL who is providing the infrastructure to supply that gas. Out of around 300 GAs, we operate 72 GAs. This talks about the volume trends. If you can see 2 pies on the left pie, if we see, our marketing mix comprises more of imported, around 60%. When you talk about transmission, which is around 70% imported, rest is domestic. We do 101 MMSCMD of natural gas marketing out of the total 200 supplied in the country. So market share is more around 50%. In terms of transmission, we do 127. Coming to the infrastructure, if you can see all the green and the black lines, total operational pipelines in the country is around 25,000 kilometers. GAIL operates around 16,000 kilometers. Why I want to bring this map in particular was that earlier infrastructure was not available in the eastern part of the country, either in forms of pipelines or regas terminals. But with the commissioning of Dhamra terminal on the east, I don't think we have a mouse here. So we have connected Dhamra to the entire eastern part. We are going up to Guwahati and even the northeastern states. This map shows where are the regas terminals. When I say regas, it is the LNG import terminals where LNG is imported and put in the gas pipelines. We have a capacity of 52 million tons, which is more than 170, 180 MMSCMD. And more regas terminals are coming up, which are getting interconnected with the pipelines. With the paucity, I'm not running into the... this map, we specially brought it for the eastern sector, in particular Jharkhand, West Bengal, Bihar, and Orissa, where you can see almost all areas have been connected with pipelines. So name anybody, we can either link a spur line or the customer would be on the main line. We have a Dhobi-Durgapur section, around 524 kilometers of pipeline run in Jharkhand. We have a Bokaro-Angul-Dhamra section and Hazirabad-Ranchi. So when we talk about Jharkhand, in particular today, it is connected with all sources of gas which can be made available in the country. So bring gas anywhere in the country can be supplied to Dhamra. We have some CPM sources also, but they are small in nature. Today we are supplying around 2 MMCMD of gas in Jharkhand. Our major customer is HUL Sindri, along with the city gas. We are tying up with Tata Steel, Hindalco, Vedanta, and some of the other steel plant SAIL, we are in discussion with. We have 11 CGD GAs in Jharkhand, out of which...
Please conclude, sir.
Yeah, 5 is operated by GAIL. Some of the benefits of natural gas which have been already discussed is the carbon emission is significantly low when we use natural gas. The western part of the country, steel plants are already using natural gas and they are reaping those benefits. Coming to the industry, it's a very clean fuel, as we say, but even the transaction of doing business in this industry is very clean. The pricing is transparent, the tariffs are transparent, The supplies are done at your doorstep, measured in energy. So everything is a transparent system in this. We have a regulator called PNGRB who regulates our tariffs. Once again, the benefits is we have it's a cleaner fuel, higher thermal efficiency. And it's, I think, a bridging fuel to hydrogen also. Like if you have a natural gas-based stuff, hydrogen can be blended or even shifted to hydrogen tomorrow. We have a lower carbon dioxide intensity, very less NOx and SOx, and a lot of savings in terms of no storage is required, no waste is generated, no slugs, nothing in terms of natural gas. As GAIL, we provide a lot of commercial and operational benefits to our customers. We have a diversified portfolio. So if a customer looks for a LNG or a domestic gas, we have options to supply multiple priced gases. We provide the infrastructure to the customer at his doorstep. He doesn't have to go anywhere. The gas comes to him at his doorstep, something if you're using your PNG at your home, at your burner tip. We offer gas is available in multiple indices. I've listed some WIM, JKM, crude HH. The advantage of these indices is sometimes people feel we should buy crude linked, JKM linked or HH linked. But multiple indices provides diversity and volatility of one index is sometimes absorbed by the other index. So that's a beauty in terms of the commercial aspects. GAIL supplies domestic gas also. We have HPHT and MDP also. Sometimes customer looks for, say, I want a domestic gas only. So that flexibility in terms of pricing, we do provide. Last and not the least, as I said, gas is a liquid and a transparent market. So hedging options are there. Of course, there's a new terminology, maybe, but in long-term gas pricing, we do a lot of hedging, wherein you can get a price stability and a predictability in long run. Thank you, sir.
Thank you, sir. Our third speaker is Mr. Varun Jindal, CEO, Dev Energy. The topic is circulating fluidized bed gasification, paving the way.
Good afternoon, everybody.
Should I introduce yourself? He has completed his technical and managerial education from prestigious institutions like Delhi College of Engineering, MDI, Gurgaon. In past 25 years, he has successfully integrated his on-the-ground experience, his technical knowledge and business acumen to build capabilities in the areas where a few Indian companies have presence.
Then we'll talk about the syngas and sustainability, which is the topic for today's conference. So these are our core values. Innovation is a difficult core value to carry in India because everybody wants a risk-free project. Nobody wants to be the first. So I saw it as an opportunity in 2000 and have continued on this path for 25 years. So what we do in the last 25 years, we have sold gasification systems for thermal application. That is for reheating furnaces, pellet plants, tile plants, wherever you need heat. So we replace PNG, LNG, propane, anything which is expensive, furnace oil, with coal gasification. And we take turnkey solutions end to end because nobody wants to take the partial risk, from coal handling, gasification, even furnace modifications, burners, everything. So what is different about our technology? We propose a fixed bed double stage gasification where the volatile matter is treated separately and the gasification gas is treated separately. And surprisingly, it has still remained a sort of, I am the only technology provider with this technology. There are other people providing single stage technologies. So what is our advantage has been consistent sort of implementation and factory produced. We don't make anything at site. Everything is standardized. Everything is done to quality standards, controlled pricing and execution. You see, an Indian buyer for technology needs a package. If you as a company can provide design, engineering, solution, implementation and operation, then the risk is mitigated. And that's why all these first. So this has been the bedrock of our growth and innovation. You sell the first, success it, and then many people follow. These are our partners. Most of these are people from China, because this is the sweet spot I've exploited in last 25 years, is to get technologies which are in China into India. Almost all the largest steel and ceramic producers are my customers. Some of the operating plants, these are gasifiers supplying to stainless steel, pellet plants, various industries across India. All these are running operating plants from 5 years, 10 years, even the oldest one is 22 years. This is a glass plant. Out of China, only glass kiln running on coal gasifier. These are ceramics. So even these tiles which are laid here, all these tiles are made on coal gasifier. So the gas can be cleaned to an extent that a designed tile can be made on a coal gas. So now coming to the topic for today, what can we contribute to sustainability in steel? We can contribute the use of coal, but in a fashion that it is suitable for environment and economic. So what is the path? The path is syngas. And how do we use it? So as everybody is aware that BOF route, we are at 2.3. Now if we go to DRI route, we can drop to 1.4. But then running a DRI vertical kiln with natural gas is very expensive. So therefore, what happens is that to intermingle economic viability with reduction of coal CO2 emission, what you do is you move to syngas plus vertical DRI, and then slowly you add green hydrogen. Because most, as Dr. Panda from SMS was saying, that you build up a, ThyssenKrupp is doing that, you build up a plant with hydrogen and then slowly keep hydrogen. This plant, the vertical kiln can be made with designed with hydrogen up to 80%. Start with syngas, and then you can keep adding hydrogen as the economics make it viable. And you can go down to almost negligible levels of CO2. So what is the gasification we are offering? It's a fluidized bed gasifier. Why fluidized bed is because of the Indian coal characteristics. And then you clean the gas, then you water shift it because the reduction process needs more hydrogen. So you reach a hydrogen CO ratio which the process will demand, and then you remove CO2 and H2S, and you get a clean syngas. So how do you integrate it? You integrate it with the vertical kiln, where there is a basic diagram is there is a gas heater, then a reduction shaft, then the off gas is again recycled by CO2 removal. So we are working with technology providers to integrate the three blocks, the scrubber, CO2 removal, and gas heater also in such a way that a low economic cost model can be developed, where because you have a CO2 removal, a gray box here and there, so they can practically be merged. So that all engineering is happening. So why CFB is because Indian coal is high ash, so entrained bed is not a good solution. And you need a gasifier which can take fines. So CFB is the only solution, and there are working plants in China for this technology. So this is the basics of the technology, and the circulation loop is what makes it really efficient. And these are simple CO shift models. They are normal temperature shift reactors, not cryogenic, not high temperature, making them very economically viable. This is the CO2 H2S removal, no rectisol, no expensive equipment. This is MDA wash, because the variables, because there is no tar and dust coming from the gasifier. Therefore, you can do this technologies. This is what a plant looks like. And this is what the DRI kiln looks like. Now, what we are working on is that all these equipment can be made in India with the help of technology provider providing design engineering, so that we can give a 0.5 million ton, or so the range I've written is 0.25, but the sweet spot is around 0.5 million ton gasifier plus vertical DRI kiln. This is what the kilns look like. So all these photos are from our partners. So another idea which I explained was green hydrogen. So what is proven is that you can run the clean with up to 80% hydrogen. But as you keep getting green hydrogen, you can keep shifting the syngas and ratio. So we have done this working where this is the green hydrogen, this is the syngas, and they can be easily mixed at the inlet of the gas heater. So the essential last point here is that how we mitigate the risk. The risk can be mitigated by seeing the components in their isolation and whether they are working or not. So gasifier is working in China. This is our partner who has a stable working systems which we can showcase, and these are the DRI partners who have stable working solutions for DRI, and we can offer you an integrated solution. Thank you.
Thank you, sir. Professor Bankim Chandra Roy has a train to catch. So I would request Chairman, sir, to kindly facilitate him in between.
Thank you, Professor. We really appreciated your time, and the presentation which you made is enlightening. But I catch, if I have summarized your entire presentation in one line, then I'll tell how to make steel smarter is something, it will remain in me. And FRP, you gave an excellent example. Thank you for sharing this experience with us. Thank you. Thank you very much.
Felicitation of Professor BCD. Thank you very much, sir, for your valuable words. And now it's up to moderator, sir, please.
The fourth paper is on Waste to Wealth, a better resilient world. This is by Mr. Anil Pasari, Director, Urvarak Industries Private Limited. He has about 30 years of experience in mineral processing and given engineering consultancy for 3 iron ore pilot projects of 1.2 million TPA capacity each. He is Director of Pasari Mineral Private Limited and Urvarak Industries Private Limited. Over to you, sir.
Thank you, Macon, for calling me for this great occasion and giving me an opportunity to give my presentation. And from last 2 days, I am hearing about the meeting and sustainability. And I am going to give a very practical approach and very possible approach for making green steel. How to make our steel industry green, not directly by reducing the carbon, but by indirectly consuming the waste into wealth and supporting the circular economy. First, as you are a steel manufacturer, you have to consider me to be a farmer and consider my headache as an opportunity to give me a solution for that. When we are doing agriculture, we have a problem of acidity of the soil. So when the soil gets acid because of lot of application of fertilizer, by leaching of the alkalinity of the soil becomes acidic. Everybody knows that we have to do a circular, you can say crop rotation, as which we have read in our childhood days, that we have to grow cereals, then we have to grow pulses, then we have to grow oil seeds. But now, because of the commercialization of the agriculture industry, now farmers are repeating the crop. So when they are repeating the crop, the soil is becoming deficient of the particular nutrients, and that soil does not get the time to get it balanced. And because of all these two problems of application of fertilizer as well as application of not doing the crop rotation, the biotic and abiotic stress management of the crop has been depleted, and that is the reason was the immunity system of the crop has gone down, and for that farmer has to apply a lot of pesticides and to combat the stresses, and these all pesticides are leading to the residual pesticides in our food chain, and that cause the cancer, that cause the problems in our health, and the aroma of the quality of the food also has gone down. So these are my headache. I am an agri, if you consider, and these are my headache. But I simultaneously, I will request that I have also solution, and you can take that solution as an opportunity to meet your requirement. So when a crop grows, it requires basically 18 elements, out of which carbon, hydrogen, oxygen is given to it by nature, and NPK, that nitrogen, phosphorus, and potash fertilizer are given by the chemical fertilizer. Along with this, crop also required 12 elements, that is calcium, magnesium, silicon, iron, manganese, copper, zinc, boron, cobalt, nickel, chlorine, and sulfur. Out of these remaining 12 elements, steel slag have 5 elements, which you can very well see in the analysis which is given there. And I brought some samples of the slag also. You know very well the steel slag, how it looks like also. So it is very common, and we have converted it into a fertilizer, and that is also very common. So, and it is the best part that it can be used as a, what you can say, along with the chemical fertilizer, along with the cow dung also. So it is compatible to a natural farming as well as chemical farming. It also helps for the restoration of the carbon from the nature, because when this steel slag is applied to the soil, it absorbs the carbon dioxide and get converted into calcium carbonate, and this is how it helps for the carbon capture from the nature and help for the carbon reduction of the system. Moreover, I have also recently done some research which is still going on. I have applied 100 kg of my steel slag into an agriculture field of 1 acre. The carbon content of the soil was 0.2% at the starting, and when I have done the application of my material, and after the end of the crop of 150 days, the carbon content of that soil goes from 0.2 to 0.3. If you calculate the volume of the mass of the soil, which is approximately in 1 acre of land about 300 thickness, it is about 3,600 tons. And if you convert that 3,600 tons of soil having 0.2% carbon, and now it got 0.3% carbon, it's a very simple arithmetic that now you have captured almost 3.6 ton of carbon from the nature which is there. And it is a established thing. POSCO Steel is doing it, and now they have done that, okay, for greenhouse gas emission, they are getting a carbon credit also. So same thing if POSCO is doing, if Nippon Steel is doing, I request why not Indian steel manufacturer can also adapt the same thing and do it in India. This is what I am graphically representation of my circular economy. From the mother earth, we are taking out minerals, manufacturing the steel, and from the steel, we are generating a lot of slag. And this steel slag, when we convert it back to the soil, as a soil, it replaces the sodium ion by calcium ion, and sodium ion leaches out from the soil, and the productivity of the soil also increases. This is the technology. Then silicon gets deposited on the leaves of the plant, which by the help of the sun rays, it breaks the water molecule into hydrogen and oxygen. Hydrogen is released to the soil, and in exchange of that, elements are absorbed from the soil for the growth of the plant. Magnesium is a chlorophyll content. Iron and manganese give the root growth, flower and fruiting growth of the plant. So all the 5 elements of steel slag are very well consumed by the plant. And now, as everybody was telling about the sustainability model, this is what I will show you. This is a very simple technology to convert your steel slag into fertilizer. These are, our country is having about 400 million acres of farmland. 40 million tons of steel slag fertilizer is required, as a rough calculation that about 100 kg of application. America is applying 1 ton, almost 400 kg of steel slag every acre of their land. So why not we can do it in India also? These are the benefit of when you apply steel slag as a fertilizer. These are the commercial benefit what a farmer get when he applies a steel slag into fertilizer in his soil. He also get a benefit, because if he spent 1,400 rupees per acre of his land, he earns about almost 14,000 in 2 yield of this crop. So he is getting a 1,000% return on his investment. You can very well see the difference of the growth on the plant. In the left-hand side, the farmer is holding 3 crops, 3 plant yield, and in comparison to a Kasima applied field, and you can see the volume of the growth. And you can see some practical samples which I have brought also. The crop that in the left hand side is holding is the fertilizer has been applied, that steel slag has been applied. And in the right hand side, the field which is not having this steel slag fertilizer. This is giving a repeated yield also, fifth crop also giving a yield of almost 22%. It is applicable to paddy, cereals, and even to oil seeds also, to wheat also.
Kindly conclude, sir.
This is what I can tell you about the economics part. This is the cost of production of our material when you get converted. In 3,750 rupees is the cost of the production, and we are selling it at a price of 7,500 also. Still, farmers are getting at a 15,000 also. So it's make a economical model also. So it is beneficial to the steel industry, beneficial to a fertilizer manufacturer using steel slag, beneficial to the farmer. So it is a complete sustainable model. Without any support, it can still make the carbon-free world. These are the economics of a project, because unless until you make an economical model, it is not possible to make a business sustainable. And this is how we are going to make 5 plants in the world. In India, we have a plan to put 5 regional plants so that we can meet to the requirement of the country. Thank you.
Thank you, sir. Our fifth and the last paper is on use of biochar as alternative fuel. This is by Tata Steel, Mr. Sachit Kumar Maji. He is currently working as principal researcher at corporate R&D, Tata Steel, Jamshedpur. He holds a PhD in chemical engineering from IIT Delhi with 17 years of rich experience in the development of solutions in the field of energy and environment like gasification, pyrolysis, CO2 capture, catalysis for sustainable development and project management. Dr. Maji has played a significant role in the development of the gasification and STC facility at Tata Steel. He was a Canadian Commonwealth Fellow under the supervision of Professor Wang Q at the University of Saskatchewan. After his PhD, he worked for refining R&D at Reliance Industry Limited at the level of research scientist and senior research scientist. He has secured 7 granted patents, 5 US and 2 Indian patents, 2 Indian patents under approval. He has published 10 international peer-reviewed journals and 12 national and international conference papers to his credit. He has successfully completed more than 10 root cause analysis reports and 15 technical reports. Over to you, sir.
Thank you, sir, for your well introduction. So, good afternoon, all dignitaries, and thanks, Mekon, for inviting me for this lecture. So, I will be presenting that how biochar can be implemented in the steel industry. So, if you see that sustainability indicator in the steel industry, so generally there are 2 processes on an average. So average, this is the BOF, so this accounts 70.4%, rest is our share electric arc furnace, and it is accounted 29.1%. So average carbon CO2 intensity is 2.32, whereas the average DRIF 1.43, whereas scrap it is 7.0. If you see that all emission in 2023, it is approximately 1.992 ton of CO2 per ton of crude steel. So if you see here that what is the possible pathway to mitigate the CO2. So basically there are the multiple ways, but mainly we are divided into the 4 ways. One is carbon capture and utilization. So as you know, carbon capture is a well-established technology. We can implement directly as such through either amine-based process or some absorption process. But utilization is a major concern. How to utilization that CO2 into the useful commodity, or how CO2 can be mineralization for certain application. Second is energy efficiency and process optimization. We can use or we can optimize the process to save some extent of CO2. Third one is carbon direct avoidance. So this is basically, we are happy to announce that we are successfully implemented or that successfully given trial hydrogen injection as well as biochar injection in multiple application like DRI as well as blast furnace application. Fourth one is that renewable energy integration, that is powering as earlier speaker already told in details, hydrogen as well as in some natural gas injection. So if we see that the biomass, why this biomass is, as a raw, because of the high moisture content, high volatile percent, we cannot inject as such in the steel making process. So if you see that, if you categorize the biomass in a different way, one is industrial biomass or carbonaceous feedstock come from industry. So that is nothing but a sewage sludge, fiber or wood proceed from the residue. Another is agriculture waste. Third one is forestry, and fourth one is organic waste. Here I want to say that all, because of the need of some strict regulation of the government, all biomass cannot be used in our application, because we need clearance. So because of the as per the norms, we cannot take. So mostly as per our past experience, we can use as a grace kind of like bamboo or some or agriculture residue or juliflora, so-called babul. These are the three commodity we can use in our application. But here again, one of the glees, since that we generally replace the carbon with carbon, so there has to be some fixed carbon. We cannot use like a fixed carbon of PCI is 77, but we are replacing the biomass with only 40% of that fixed carbon. So fixed carbon is play very important role in each and every application in the iron making process. So, so as I said that biomass as such we cannot use as a that any of the application because the high moisture content, high VM. So what is the process? Generally, if you biomass treat or in absence of oxygen, so-called pyrolysis, then based on the heating rate, we can categorize a different process. One is called, if it is a low temperature process, below 300 or 250 degrees centigrade, it is called torrefication. Slow pyrolysis, fast pyrolysis, and that is gasification process. So basically, based on our demand, we can mimic the process. If you need a high content of solid residue, so-called biochar, we can generally process the slow pyrolysis. If our demand is gas, then we can go through the gasification. Also, fast pyrolysis is also one of the the process that we can. If you need a bio oil, then that fast pyrolysis is a process. Generally, all the pyrolysis is well-established technology, pyrolysis technology. Only thing is that when is a liquid product, so-called the bio oil, it's not commercializing the value, or I mean, it is end application. It's not established. It is only in the pilot stage. So basically, these are the two commercial technology, biomass to bioconversion. One is a fixed bed process, fixed bed or moving bed process. One is a rotary clean. If you want only that we know both that gas as well as that char, no liquid, then generally we prefer that fixed bed process. If you need three product, gas, liquid, also biochar, then we can go through our rotary clean process. So basically, these are the few processes that we can use in our application. So basically, these are the process we can use in the different, and up to 0.8 to 1.58 ton of CO2 per ton of crude distill, you can save through these process. But here DRI is not account. It will increase to up to 2.2 process. So basically, our past experience is hydrogen injection. I said our expert Sujan Hazra is there. He is done during our whole course of trial. So up to 6 kg of hydrogen, per ton of hot metal can be, we have already implemented. We have used blast furnace application as a PCI. We are still on continuation up to 10 kg, 10% of replacement. We also use ferrochrome submerged arc person up to 10%. Also replacement of coal in DRI process up to 13%. So these have already established. So we have in the Tata Steel in R&D, we are a three facility we have developed. One is the 10 TPD ton gasification for any kind of feedstock. When there is a wet biomass, we can go through the hydrothermal carbonization. Another is a fluid bed process for the gas solid reaction, like reforming reaction, hydrogen reaction, or pyrolysis process. So what is the challenges? Basically, because the biomass is different due to the FC carbon. We have a variable biochar quality. Supply chain is the major problem in our system. Since biochar is a lot of alkali is there, so we may need a furnace design and modification for particular process. Cost is also application, because that transportation is one of the biggest challenges in the biomass transportation. So what is the conclusion? It is a sustainable carbon sources because that is a carbon neutral process. We have if we use biochar, it is great and environmental benefit. Challenge but there is some challenge like quality, cost, and scalability require ongoing research and supporting policy. Also, global climate alignment. Adopting biochar align with the global climate change effort and sustainable industrial practice. Thank you. Thank you, sir.
Thank you. So we are running late, so due to paucity of time, we can take two questions. The rest of you can discuss over lunch. So any question?
Not a question, only Mr. Anil Saab, what he was explaining about this, I think that is the best example of this sustainability. What we were talking during panel discussions, you will find a huge heap of slag while going to Jamshedpur or anywhere where steel plants are there. If that can be utilized in our crop, I think best example of sustainability. That's all.
Anybody else? Yeah. Please give the mic.
You have shown, my question to Dev Energy, you have shown 1.2 to 1.5 ton CO2 per ton of crude steel. So have you achieved this figure in DRI EF route?
So currently there is no plant right now running on CFB gasification with DRI. But on theoretical calculations, yes, everything has been calculated and proven because up to DRI,
Yes.
right? If you understand the reactions and you understand the quantities of coal, then syngas, then DRI, and the metallization level, then you can very surely estimate to plus minus 5% what is the CO2 emissions. And you can find, so this is our working, and you can find numerous journal papers by various experts where the mean number is between 1.4 to 1.5 ton per ton of DRI.
But sir, we have taken some figure from JSPL Angul that gives more, because they are running syngas based DR plant.
So that is why before answering your question, I understood, and that's why I said CFB gasifier, and I didn't say, so fixed bed gasifiers have slightly different take, and also, as I said about process gas heater, so there are multiple ways to reach that number, and also you have to get into the details of technology. Yes, it is possible. I think the Angul number is in the range of 1.7, if I'm not mistaken.
Not sir, more than that.
Okay, so there must be some other processes happening in terms of the fixed bed gasifier, but the CFB gasifier, because there is no tar, there is no phenols, and the energy conversion is very high, therefore this number is absolutely achievable.
Okay. Thank you, sir.
May I request the session chair to kindly sum up the entire session? Okay.
Just one question come observation. When I heard Mr. Anuj regarding availability of natural gas all across, I find it is available very close to Bokaro, it is available at Durgapur, Raurkela, and very soon it will be available at Bhilai, and also at many places, Angul and all, where a lot of steel units are there. As I understand, even after this spread in terms of availability, usage of natural gas in steel making remains minimal. Maybe MNS is doing in DRI, but and as I understand, there is a sort of issue related to pricing. The pricing which has been inconsistent because of major part of natural gas being imported in form of LNG. So my question is how you address this issue and mitigate this fear of high fluctuation of natural gas prices. Because if we use natural gas, we are definitely going to improve our carbon footprint. Thank you.
Thank you for the question. You're very right, sir. Pricing or the costing is always a concern between your business. And natural gas has been experienced by the western and the northern part for over like 30 years since GAIL was formed. And it has been a very competitive fuel on a longer horizon. The eastern part, the pipelines came somewhere in 2020, 21, when we had seen a lot of geopolitical issues, COVID, Ukraine war, things like that. There was huge volatility in gas prices, definitely. But going forward, what we can assure you is, if you recall my third or fourth slide, a lot of internationally LNG is available. A lot of investments have gone in, and we are seeing a lot of surplus availability of imported gas. A lot of infrastructure has gone in, even in the country, for production of domestic gas. The government has a vision to bring natural gas to around 15% from the current 7%. There's a regulator already in place for transmission tariffs. So, being a liquid commodity, we are very confident that in coming years, right from 25, 26 onwards, the prices would be lower and range bound, very competitive to other fuels. The advantages which I can say in terms of pricing is, being a traded commodity, we can use various instruments like hedging, etc., to get fixed prices, reduction volatility. Even gas is available at various indices. We can have crude linked, internationally HH linked, and things like that. So with all this stuff, even the western part of the country, AMNS or JSW, they are experiencing all this latest instruments in terms of pricing. So with all this, the price can be definitely made competitive with respect to other fuels. Infrastructure, I've already explained that as GAIL, we are putting a lot of infrastructure in the eastern side. Any customer who feels needs a connectivity will be more than happy to connect them to their doorstep. Thank you, sir.
Sir, can I comment one line on this? Sir, the way to